folks, welcome to the lesson Solving Simultaneous Equations by Elimination, video number 2. If you haven't seen video number 1, you really should see that because it'll make this seem much easier and straightforward, and that's the name of the game, making your maths seem easier. So let's crack on, get the job done. Here's our first example. We've got a different number of x and a different number of y, and we need the same number of one of those letters. We, as ever, label the equations, and we're going to change one of the equations to make sure we've either got the same number of x or the same number of y. And it's easiest to change equation 2 to make it have the same number of x as equation 1. And to do that, we multiply that second equation by 2. That will give us 2x. When we multiply equation 2 by 2, we get 2x plus 6y equals 18. Make sure you multiply everything in the equation by 2. Call that equation 3 if you like, and then equation 1 is just as given to us. Now we have the same number of x. They're both positive x, they're both positive 2x, and therefore when the signs are the same, we subtract the equations. When the signs are the same, we subtract the equations. And when we do that, we end up with y equaling 2. We then substitute that back into one of the equations to find our x value, substitute it into equation 1. You could have used equation 2 if you wanted, but I've chosen equation 1. And that becomes 2x plus 5 lots of 2 equals 16. So that's 2x plus 10 equals 16, and that gives us x equals 3. So we think those are the right answers. Now we're going to check. So we substitute x equals 3 and y equals 2 into the two equations. When we substitute them into equation 1, we obtain 2 lots of 3 plus 5 lots of 2. Does that equal 16? Yes, it does. And in equation 2, x is 3 and y equals 2 substituted in gives us 3 plus 3 lots of 2 equals 9. Is that correct? Yes, it is. They fit both equations. We've got the right answer. On to example 2. The first thing we do, number the equations. We then wish to get either the same number of x or the same number of y. And we're going to multiply the first equation by 3 to give us the same number of y's. So when we multiply the first equation by 3, remember you multiply everything by 3. 6x subtract 3y equals 33. And equation 2 we keep as is. That's just 5x minus 3y equals 24. We now are looking at the y's as they are the same and the signs are the same. They're both subtract 3y. So the signs are the same, therefore we subtract the two equations. And when we subtract the two equations, we end up with x equals 9. We now substitute x equals 9 into one of the equations. I'm going to choose to substitute it into equation 1. And equation 1 gives us 2 lots of 9 minus y equals 11. So 18 take away y equals 11 must be y equals 7. So x equals 9, y equals 7, we think are the right answers. But now we're going to check. We check by substituting x equals 9 and y equals 7 into both equations. In equation 1, we end up with 2 lots of 9, subtract 7 equals 11, i.e. 18 take away 7 equals 11. Yes, it does. And in equation 2, 5 lots of x subtract 3 lots of y becomes 5 times 9, subtract 3 times 7 equals 24. 45 take away 21 equals 24. Yes, it does. We know we've got the right answer. Here in example 1, we either need the same number of x or the same number of y. In either case, we cannot just multiply one of the equations, we have to multiply both. So we start once again by labeling the equations 1 and 2. We're going to multiply the first equation by 2 and the second equation by 3 because that will give us 6x in both equations. So equation 1 times 2 gives us 6x plus 10y equals 28, and equation 2 times 3 gives us 6x plus 9y equals 27. We look at the x's, they're both positive 6x, i.e. the signs are the same, so we subtract the equations, and when we do, we get y equals 1. We substitute now y equals 1 into one of the equations. I'm going to substitute it into equation 1, and we end up with 3x plus 5 lots of 1 equals 14, and then that gives us x equals 3. So we think they're the right answers, but we need to check. And when we do check, putting x equals 3 and y equals 1 into the first equation, we end up with 3 lots of 3 plus 5 lots of 1. Does that equals 14? 9 plus 5 equals 14. Yes, it does. And when we put x equals 3 and y equals 1 into the second equation, we get 2 lots of 3 plus 3 lots of 1. Does that equal 9? Yes, it does. We've got the right answer. Moving into example 2, I hope we're kind of remembering the first thing we do, we number the equations, and again we're going to try and get rid of the x term. So we multiply the first equation by 5, that will give us 10x plus 20y equals 60, and we're going to have to multiply the second equation by 2 in order to give us 10x. And we get 10x subtract 6y equals 34. We look at the x's, they're both positive 10x, i.e. the signs are the same. If they're the same, we subtract. And when we subtract those two equations, just be careful. 10x take away 10x, the x's cancel. But when we're subtracting the y term, we've got a subtract here and we've got a negative here. We're subtracting negative 6y. And that subtracting of the negative 6y is going to give us plus. We're going to actually be adding 6y. So we're actually going to end up with 26y, and 60 take away 34 equals 26. That's nice because it tells us that y equals 1. And we substitute y equals 1 into one of the equations, the top one, and we get 2x plus 4 lots of 1 equals 12, and that gives us x equals 4. So we think x equals 4, y equals 1 is the right answer, but we're going to check. And when we do our check, we put x equals 4, y equals 1 into the first equation. We get 2 lots of 4 plus 4 lots of 1. Does that equal 12? 8 plus 4 equals 12. It sure does. And in the second equation, we get 5 lots of 4, subtract 3 lots of 1. That's 20 take away 3, and that gives us 17. We've got the right answer. Let's put this all together then in a recap. The first thing we always do, label each equation number 1 and number 2. Decide, is it easiest to eliminate the x's or the y's? It doesn't matter, just be careful whatever you do. In this case, I'm going to eliminate the x's, so I need to multiply the top equation by 2 and the second equation by 3 to give me 6x. Now, because those 6x's are both positive 6x's, the signs are the same, i.e. both positive. If the signs are the same, then you subtract the equations. And when I do subtract the equations, I end up with y equals 1. We then substitute that value back into one of the equations to find x. I'm going to substitute it back into equation 1. And when I do, I get 3 lots of x plus 5 lots of 1 equals 14. And then I end up with x equals 3. I think I've got the right answer, but let's check, and you check by substituting both values back into the two equations. So you substitute x equals 3 and y equals 1 into the first equation, and you get 9 plus 5 equals 14. That's correct. And then you substitute x equals 3 and y equals 1 back into the second equation, and you get 6 plus 3 equals 9. And that's correct. You know you've got the right answer. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.